So another type of National 5 calculation that you might be asked in the National 5 exam is what's called a volumetric titration calculation, or just a titration calculation. The question will tend to give you a bit of spiel with some values in it, and then it will give you a balanced equation, or an equation, and you're asked to balance it. So what I've done here is I've laid out a question, I've laid out the balanced equation as well. So let's just read through the question and see what we're actually being asked. So calculate the concentration of potassium hydroxide when 25 centimetres cubed of potassium hydroxide is neutralised by 17.5 centimetres cubed of 0.1 mole per litre sulfuric acid. So when you read that, you've got a lot of different chemical names and you've got a lot of values coming at you. So it's easy to get overwhelmed. What you want to do is just break it up simply. So what I would tend to do is split it into two different columns. A column for your sulfuric acid and a column for your potassium hydroxide. The only two things you're asked about in the question are potassium hydroxide and sulfuric acid. So you can ignore your potassium sulfate and you can ignore water. They've got nothing to do with the question. They're only there just for context and to complete the reaction. So what you do is you have NCV listed for sulfuric acid and NCV listed for potassium hydroxide. Think of it as two different columns with two different headings. Now what you do is you input values that you know. So calculate the concentration of potassium hydroxide when 25 centimetres cubed of potassium hydroxide is neutralised. So 25 centimetres cubed is the volume of potassium hydroxide that we have. So potassium hydroxide column, what we're going to do is put in the volume. So 25 centimetres cubed. However, when we're talking about concentration, we're talking about litres. So to be consistent, we need to put this into litres as well. Times 10 to the negative 3 litres, L for litres. Now what else do we know? We know that is neutralised by 17.5 centimetres cubed of 0.1 mole per litre sulfuric acid. So 17.5 centimetres cubed of sulfuric acid. You want to input that into your other column here. So 17.5, again, remember to put it into litres. Always remember to put it into litres. And what else do we know? Well, we know the concentration of 0.1 mole per litre sulfuric acid. 0.1 mole per litre. So we know a concentration, we know a volume. What can we work out? Well, we can work out the number of moles, because we don't know number of moles, but we do know concentration and volume, referring back to that triangle there. So we work it out by multiplying C by V. So 0.1 multiplied by 17.5 times 10 to the negative 3. What that gives us is 1.75 times 10 to the negative 3 moles. So if we have 1.75 times 10 to the negative 3 moles of sulfuric acid, we can work out the number of moles of potassium hydroxide we have, and subsequently work out the concentration, which is what the question's asking. First of all, we need to look at is the mole ratio. So can we directly just transfer the number of moles over from sulfuric acid to potassium hydroxide? Well, we can. What we need to do, in that circumstance, it would have to be a 1-to-1 ratio, but what we have here is a 1-to-2 ratio. So let's say we had 1 mole of sulfuric acid, we would have 2 moles of potassium hydroxide. And if we had 5 moles of sulfuric acid, we would have 10 moles of potassium hydroxide. So what we need to do is double the number of moles when we're transferring that number over. So we need to double it, so it's 1.75 times 10 to the negative 3 moles multiplied by 2, which gives us 3.5 times 10 to the negative 3 moles. So 1.75 times 10 to the negative 3 moles of sulfuric acid reacts with 3.5 times 10 to the negative 3 moles of potassium hydroxide. Now we know a number of moles, we know a volume, and the question is asking about concentration. So what we do is we refer back to a triangle. This time we know the number of moles, we know the volume, we need to work out the concentration. So we do so by using a rearrangement of that formula, which gives us number of moles over volume, 3.5 times 10 to the negative 3 divided by 25 times 10 to the negative 3, which gives us 0.14 mole per litre. And there's our final answer. So calculate the concentration of potassium hydroxide. Concentration of potassium hydroxide is 0.14 moles per litre. So if we just think about the steps that we took to work out that value, first thing we did, split up into two different columns, the thing that we know, which is sulfuric acid, and the unknown, the thing we're going to calculate, which is potassium hydroxide. List what we have, so jot down your NCV, NCV, leaving any blanks when you don't have a value. We did have the value for concentration and volume, which meant that we could work out a number of moles of sulfuric acid. When we transfer that number over, we have to take into account the mole ratio, which is a 1 to 2. There's no number in front of the H2SO4, so you assume that it's a 1. So we transfer that number across, multiplying it by 2, which gives us the number of moles of potassium hydroxide. We know the volume of potassium hydroxide because it's given in the question. Therefore, we can work out the concentration by rearranging this formula to give us C equals N over V. Our final answer is there. It's really important to show your working in questions like this because it is easy to make calculation errors. We all do it. Let's say, for example, you didn't take into account the mole ratio. Yes, you would lose a mark. However, you have shown that you've worked out a number of moles and then you have made a mistake in your calculations. However, if you worked through this and you still got a concentration value, it would be wrong. However, the error would carry through, so you would still get 2 out of 3 marks. Let's say this was a 3-mark question, so it's really important to show your working and not just to write the final answer. So don't plug into a calculator, lay it out like this, which means the examiner or the person who's marking it will be able to see, okay, what has this person done? Okay, they've made a wee calculation error there, however, this is right, and then this is carried through, so they'll still get the marks for it, okay? So it's a volumetric titration calculations.